welcome back. In this lesson, I want us to discuss isomers. Alright, what are isomers? And also we're going to look at the three different structural isomers. Isomers are basically divided into two types of isomers. We have what we call stereoisomers, but we don't do these in our syllabus. So we're going to concentrate on the structural isomers. The other name for structural isomers is constitutional isomers, but we use the term structural isomers. Okay, structural isomers are divided into three groups. We have what we call chain isomers, and also we have what we call positional isomers, and we also have what we call functional isomers. What are structural isomers? Structural isomers are organic molecules with the same molecular formula but different structural formula. Some texts will say different connectivity, right? So we say organic molecules with the same molecular formula but different structural formula. Like I said, we have chain isomers, positional isomers, and functional isomers. Let's discuss these three in detail. Right, chain isomers, they have the same molecular formula but different types of chains. For example, we can have butane and 2-methylpropane. What is the molecular formula of this butane? It is C4 and then H10, right? And then what is the molecular formula of 2-methylpropane? Is C4 and then H10, like this. You see that the molecular formula is the same, right? The molecular formula is the same. But let's look at the structural formula. For butane, it's just one chain, like that. We have carbon 1, 2, 3, 4, which is a single chain. But 2-methylpropane, we have this chain, 1, 2, 3, and then a branch there. Okay, we have a branch. So this one is branched, while this one is not branched. It's just one chain, like that. Chain isomers are organic molecules with the same molecular formula but different types of chains. And then we have positional isomers. They have the same molecular formula but different positions of the side chain, substituents, or functional groups on a parent chain. For example, we can have 1-chloropropane or 2-chloropropane. Right, let's check those. Okay, we have 1-chloropropane. You see the chloride group there is bonded to carbon, to the first carbon. Right, don't worry about the numbering of carbons. We're going to look at that when we start doing the naming of compounds. Right, so and then what about here? We have carbon 1, carbon 2, carbon 3. We can name the carbons from any direction, even here 1, 2, 3 is like that. This chlorine atom is bonded to the second carbon. These ones are positional isomers because the functional group is in different carbons. We can also have something like this. Where is the double bond here? This is 1, 2, 3, 4. And then this is 1, 2, 3, 4. The double bond is between carbon 1 and carbon 2. Here the double bond is between carbon 2 and carbon 3. Okay, but if you check at the molecular formula, we have how many carbons? 1, 2, 3, 4. And then how many hydrogens? 2, 4, 6, 8. Or it's an alkene anyway. So it's going to be 2 times 4, which is 8 there. Even here, we have C4H8, like that. The molecular formulae are the same, but the double bond is in different positions. Right, even here, what is our molecular formula? We have C3 and then H what? Okay, it has to be 2n plus 1. So it's going to be 7. 7, and then the chlorine atom there. Same here, C3H7, then chlorine atom there. Okay, the molecular formulae are the same, but where do we find the chlorine atoms? In different carbons. So these are positional isomers. And then the last one is functional isomers. Functional isomers, you have the same molecular formula but different functional groups. An example, if you check here, the molecular formula here will be C2H4O2. Same here, it's going to be C2H4O2. So the molecular formula is the same, but these are two different molecules that belong to two different homologous series. These are good examples of functional isomers. We've discussed the three structural isomers. We have the chain isomers, the positional isomers, and functional isomers. Remember these three.